In this lecture, we work through some examples with function composition. Let's take the functions f of x is x squared minus 1 and g of x is x plus 2, and let's compose f and g and f. In the first case, f composed with g of x is f of g of x, which is f of x plus 2, since g of x is x plus 2. F of x plus 2 is x plus 2, the quantity, squared minus 1. Work out the algebra, expand x plus 2 squared to x squared plus 4x plus 4, subtract 1. Our final answer is x squared plus 4x plus 3. On the other hand, g composed with f of x is g of f of x, is g of x squared minus 1. G takes an input and adds 2 to it, so g of x squared minus 1 is x squared minus 1 plus 2, which is the same as x squared plus 1. Let's do some more problems. We're going to find compositions of f composed with g and g composed with f. In the first problem, f of x is x squared plus 1, and g composed with f, x, and g of x is the square root of 3. Notice that g of x is a constant. No matter what we place into g, we always get out the square root of 3. So let's work through this one and get f composed with g of x, which is f of g of x, which is f of square root of 3. The function f squares things and adds 1, so let's take square root of 3, square it, and add 1. 3 plus 1 is 4. So f composed with g of x is 4. On the other hand, g composed with f of x is g of f of x. But g of anything is the square root of 3, so we know the answer is going to be the square root of 3. In summary, f composed with g of x is the constant 4, and g composed with f of x is the constant square root of 3. Some more problems. In problem 3, from an old quiz, f of x is x squared plus 1, and g is the square root function. In problem 4, f is x squared plus 5, and g is the square root of x minus 5. In problem 3, we will compose f with g. F composed with g of x is f of g of x is f of the square root of x, which is the square root of x all squared, plus 9, which is just x plus 9. On the other hand, in a different order, g composed with f of x is g of f of x. F of x is x squared plus 9, so g of f of x is g of x squared plus 9. The function g takes square roots, so g of x squared plus 9 is the square root of x squared plus 9, which cannot be simplified. So f composed with g of x is x plus 9, while g composed with f of x is x square root of x squared plus 9. In problem 4, f composed with g of x is f of g of x, which is f of the square root of x minus 5, which is the square root of x minus 5 all squared plus 5. Let's do the algebra. When you square the square root of x minus 5, you get x minus 5. Add 5 to that and just get x. So f composed with g of x is x. On the other hand, g composed with f of x is g of f of x is g of x squared plus 5 is the square root of x squared plus 5 minus 5. Simplify under the radical. X squared plus 5 minus 5 is x squared, so we're taking the square root of x squared, which is the absolute value of x. If x is positive, the square root of x squared is x. If x is negative, the square root of x squared will be the negative of that negative number. Either way, the square root of x squared is the absolute value of x. So in this case, f composed with g of x is x, and g composed with f of x is the absolute value of x. Next, we will look at chaining function together with function composition.